Hi, my name's Logan Jorgensen. I'm a software engineer. I just moved to the Chicago area in August of last year. So excited to meet people in the software industry, talk a little bit about a project I worked on back in college for a class that I was in that was like a machine learning class. And hoping that the way that some of the libraries were used in this project maybe can spark some ideas for other people. Just because I feel like this project for me was a lot of like gluing together different things and using some of the existing ecosystem of Python libraries, which is, as we all know, very awesome. It's one of the reasons that I like Python so much is there's like a library for everything. Sometimes it's maybe not the best library, but yeah. So let's get into this. So my presentation itself, I guess as a background for what this project actually is it was made for a class. I went to Iowa State. If there's any Iowa State people here, I doubt it. It got the highest grade in the class, so like that's a little bit of a flex. And then the like project itself is based around the decisions of the Federal Reserve. So for any who don't kind of have the context on what the Federal Reserve does is they're the ones that kind of make the decisions around interest rates, which has a lot of impacts on things like the interest rate in your bank account or the interest rate on a mortgage, and it has these cascading effects across the entire economy. And they regularly make these meetings to decide if they're going to bring the rates up, if they're going to bring the rates down. And that's based around a mandate that they have to keep high employment and keep inflation low. So that's like some context. And then alongside this, in this class, I was like, hey, I was reading some articles. Machine learning is kind of being used in a lot of financial forecasting contexts. So why not use Python? We were already using Python for the whole class. And the goal was basically, I had no like NLP experience whatsoever. I had never touched a package or library that used anything NLP. So I was like, let's just dive into it. Let's see if we can like do something cool with these filings from the Federal Reserve and maybe try to make some prediction system around that.
What's NLP stand for?
Oh yeah, so NLP is natural language processing. Thank you for the question.
What is that?
Yeah, so natural language processing, from my understanding, and again, as the bottom there says, I'm definitely not an expert, nor a financial expert. This is not financial advice either. Yeah, please do not make any investments based on this presentation. But NLP, from my understanding, is basically just you're working with text, normally natural language, and you're trying to extract certain features or certain details out of the semantics or syntax of the text. So I'm sure like everyone here knows LLMs are kind of adjacent to like the NLP space. But for this project, I didn't use any like LLM things. That's a little bit like, was above my pay grade at this point, but maybe in the future. So the problem itself is, as I said before, you have the Federal Reserve. Underneath the Federal Reserve, you have the FOMC, which is this committee that regularly meets a couple times a year. And they set the FFR, which is the federal funds rate. So they say, are we going to bring it up? Or are we going to bring it down? Keep the economy pumping, doing whatever. And so the challenge here is, or I guess kind of the inspiration for this, is that there's actually a term called Fedspeak that people have come up with, because when these statements are written, the committee generally tries to keep them very, very cryptic or like as plainly worded as possible, because as you can imagine, if they say something very drastic in a statement, then it's like, everyone's like, oh, well, I'm just gonna go empty out my 401k and sell everything, right? Or something like that. So obviously like the words they put out to the public can have very cascading effects on everything. And so the fact that there's kind of like this cryptic, almost like its own language of Fedspeak in these statements, I figured doing some analysis on that, maybe trying to do some sort of like feature engineering around that would be kind of cool. And then in terms of like out there in the real world, a lot of like traders, investors, people doing research and whatnot, they try to read into the statements because obviously they want to get ahead of the game. I have a link at the end of this presentation of an article of Morgan Stanley actually doing this. It's much more complex than what I am doing here. But they kind of published an article that talks about this whole thing they put out in the world, if that's interesting to you. So yeah, that's kind of the context for the problem. So we're going in with a machine learning approach. So how can we use machine learning to kind of navigate this space of like, oh, there's these statements. I know I want to use Python, but like, how do we get from the start to the finish? Like, what's the end goal here? And so kind of like formulating the solution is, okay, well, instead of having like an analyst or like a person look at these statements and kind of think about what they mean, can we train a model to kind of extract patterns from the way that the committee writes their statements and look at the way that they made their choices in the past? Can we use that to kind of analyze decisions going forward when the statements are published? Because there's like a delay between when the statements are published and then when they make a decision on the rate change. And so in terms of formulating the problem so we can break it down into code, I did basically classification of 3 possible types. So the result would be the model takes in a statement and it predicts will the rates be increased, decreased, or will they remain the same? There's other ways you could approach this, like you could have it be a numerical prediction of like plus or minus, but I went back and forth with my professor a lot on this and we were just like, just pick something. So yeah. First step was getting all of the data. Not anything too exciting, but the Federal Reserve does provide like official APIs for this. So if you want to go out and explore all of that kind of data that's out there, great tool, great resource. For the simplicity of this project, because I had a lot of midterms at the time and whatnot, I ended up just using 2 separate Kaggle data sets. So who here, raise your hand if you use Kaggle. Perchance. Okay, great, yeah. So anyone who hasn't, Kaggle's great, tons of like free data sets and stuff. So I took 2 data sets from Kaggle and just kind of like consolidated them together. And then I removed stop words, which is a term for kind of like filler words. So like and or but, things like that, that are kind of generally potentially irrelevant to what the document is trying to like have as an intent. And then I used the NLTK for that, so that's a great Python package. And then this is just like a quick, it's not easy to read, but that's just kind of like a general structure of the code. It's really, honestly, looking back at this, even a year and a half ago, this was horrible code. So actually, maybe you should look at it. But it works. So basically, combine the data sets, do a little bit of like exploratory analysis. It's like, okay, what kind of data do we have here? Make some cool charts. I think if I remember correctly, I used Plotly for this, or Seaborn, or one of those. So this was kind of cool. Like you can see, maybe there's some patterns here, just kind of like exploring the data. Verbosity is just how long is the document that they're putting out in the world. It's like how many words are in it. And so like generally, correlation is not causation, but there was some interesting things to observe with like when the rates are much lower, the documents are much longer, and things like that. But yeah, so that's kind of like getting the data, taking a look at it, what pieces of data can we work with. Then the next step was actually extracting out specific features that we want to train our model on from the data. Because when we train the model, we want to pick specific things that are like, okay, look at A, B, C, and D. Based on those features of the documents, train the model around those, rather than just having this huge mess of a bunch of random data. So the first thing here was vectorizing the words, which is basically taking all of the words and putting them in a vector space in terms of word frequency. And so I used 2 different methodologies for this. The main one is called TF-IDF, which compares the frequency of words in the document to a larger corpus of like documents out in the corpus is kind of like a larger collection of documents, basically. And I used sklearn for that. And then I also took in the documents and gave them each a polarity and subjectivity score. If you go to the text blob documentation, they have like this great explanation of like what those words actually mean, which is like surprisingly kind of complicated, I thought, because they sound simple, but like they do some cool stuff to calculate those values. So I used the text blob library for those, and then took all of these features and kind of put them into one like pandas data frame together. It's all nice and neat, ready to put into a model. So as kind of like a baseline to compare to, I built a linear regression model, also because it was a requirement for the class. But and that had like a rough accuracy on the test set of like 51.8 or something, or like 52, which is like better than random, but also not really that great. Like if you were a bank or something and you were relying on this model, that would be not exciting. So linear regression, not that great. Maybe we can make a neural network that is able to better extract these like complicated features in the text and get a better output, essentially. And so all of those features that I mentioned before, the TF-IDF, vectorizing all the text, getting the sentiment polarity scores, we have all these numbers and we can plug them into a model and train it based on that. The model architecture I experimented a little bit with, and then I tuned the hyperparameters, which I can show in a second. It's a lot of words. And again, like I didn't have a lot of experience going into this project, but for those that don't have like an ML background, the way that a neural network is structured is basically you have all these nodes in kind of like a spider web, and each node has like a weight to it. And so you can train your model to update the math on each of those nodes. And as you train it, it will generally adapt closer to your training data. And there's usually kind of like a sweet spot where you don't want to overfit your model to the data. I hope that makes sense. I feel like I still don't quite understand everything, so, and I don't think I ever will. But really basic, like I did basically the simplest architecture for that model as I could. And then the hyperparameter part is just different, like I guess you could call them like options for training the model. And I did a pseudo-random search where I basically just picked a bunch of random options and ran them all. And I think, I just kind of let it rip for a while, like I let it run. It's not the most scientific way to do it. There's a lot of research into how do you select the best hyperparameters without running every possible combination. But that's kind of, from my understanding, that's like frontier level research. So I just picked a bunch of random stuff and went with it. And then I used TensorFlow for this, specifically the Keras part of TensorFlow. So this is the results of the linear regression, just to have a little visual. And then this is that random picking of variables and just letting them all rip, what that looks like. So each of these lines represents one version of the model with a specific selection of settings. And so I trained them all on the data and then ran a prediction on all of them once they were trained, and then graphed all this out to see which model performs the best out of the, I think it was 20 or 30, yeah. And then looking, once this was determined, look at the actual values, figure out, okay, which model was the best out of this group. Looking at that specific model, you have the training accuracy and then the validation accuracy, which the training accuracy generally is going to increase over time. And as you train more and more, it's going to be fit to your training data. And then the validation accuracy, this graph is a little fishy. And again, this problem is not perfect for this project per se. So this is mostly exploratory. Again, do not use this for real decisions, please. But what my professor and I thought were interesting is, generally speaking, most of the graphs, we graphed out most of these models that we trained, besides just the most accurate one. And there was generally like a trend of the validation accuracy topping out at a certain point, like upwards and then downwards, which is typically what you see with models that work, from my understanding. Someone might be able to correct me on that. Just because as you train like too much, the model is overfit and then your validation accuracy starts to drop off. So it's really interesting that we saw like this actual curve with a peak, which was kind of cool. And maybe that's a sign of like, maybe this could possibly perhaps work, maybe. So looking at the results of that final model, it had a better accuracy than the linear regression. Still not great, but it was better. And the general takeaway was that the neural network actually like outperformed the linear regression, which was cool. And I guess just thinking about it kind of makes sense because linear regression doesn't really meet the problem at hand, which is all of these complex like textual features, which is definitely a problem that's like better suited for a neural net. And then the general limitations on this, just to like give some additional info, was the data set seems big, but in the grand scheme of things, if you think about like economics and stuff, it's kind of small. It's only from like 2001. And they only meet around 8 times a year. So it's not a lot of documents to work with, especially when you're splitting it up into training data and prediction data. And then also, because this is such a complicated thing, you can't really, like realistically, you can't just look at a document and like predict the outcome of a committee decision. So an interesting way to expand this possibly in the future or make it better would be plugging in a lot of other information from the Federal Reserve that they put out. And a lot of that could be like unemployment rates or inflation rates, and other things that kind of drive the way that they tend to make decisions, besides just the statements that they're putting out in the world. And then also, this is actually what Morgan Stanley, from my understanding, was working on, is using LLMs to take a look at these documents. When I was going through this, the popular ones were FinBERT, which from my understanding is like a fork of the BERT model. I don't know if anyone has used that before. Or Vader, which is another like kind of niche model. I think everyone knows GPT-4 for sure. And then just like experimenting with other architectures. And then, like I said here, there's actually like an index that's kind of cool. You can like see the price of it change over time of like what they think it's going to predict. And that's from Morgan Stanley. And if you want a link to any of this, I did tiny URLs in case that's easier for people to like take a picture of or remember. So if you want to read them, I wrote a Medium article on this. If you want to read that, you can go to tinyurl.com/Fedspeak. And if you want to read the Morgan Stanley article, you can go to tinyurl.com/ChiPyRocks. So yeah, thank you. Yeah.
Why don't you just pick the random neural network architecture, like plug and start or something like that?
So I did kind of gloss over like that whole process, I guess. To some degree, we just kind of like picked something for the sake of picking something, because a lot of it was like experimentation in terms of like how are we going to structure the model. But we did use like a softmax for the output. I may have forgot to put that in the slides. Oh.
What was it?
Yeah, I really wish I had the code of that in here. Actually, that's my fault. Shoot. Yeah, I guess the best I can do at this moment is if you go to the Medium article, there is a snippet of the code that kind of like has the architecture in it. And also what's really cool is like, I think my biggest takeaway from this is this sounds like, to me, even like thinking about it, it sounds so complicated. But when you're writing it in Python, like I think the file for this is only like a couple hundred lines or something, which is kind of awesome, right? Like, you can do all of this, and it's like in one jank file that you can just run in your computer. Like, that's pretty cool. So yeah, I don't have like a great answer. This was also a long time ago, admittedly, and I have not reviewed a ton of the details. But hopefully, does that answer your question at all? Hopefully.
Yeah.
Okay. Yeah, so this was for a specific class, but it was kind of like an open-ended thing. So you could pick whatever you wanted to do, really. It just had to be machine learning oriented, if that makes sense. Yeah, the class was like intro to machine learning. So I guess as context, we started by using Python. We made a neural net from scratch with no library, like only NumPy. And then we worked our way up to like using PyTorch, using more common approaches and whatnot. All right. Thank you.